Hello guys. So I got some good news for this week. We only have one new lesson of material as well as next week, and next week is going to be the last week that I'm assigning anything for homework. You will still have time to finish up, and I'm sure I'll send a message out about that later. But like I said, only one lesson that's new this week, and then probably a quiz or a Kahoot, or quizzes, excuse me. So this lesson is about finding the area of regular polygons. Now, we need to understand what a regular polygon is. We did talk about this a little bit last week, but I just want to do a quick little recap. So there's different types of polygons. An equilateral polygon is where all sides are congruent. So you could think of that as like this example down here. We have a rhombus. All of the sides are congruent, but not all of the angles are congruent. Equiangular can be anything that has all congruent angles, such as a square or a rectangle is a good example where you have all 90-degree angles, but it's not equilateral because not all of the sides are the same. Now, a regular polygon is a convex polygon that is both equilateral and equiangular. So all sides are the same, all angles are the same, just like this diagram right here. Okay, so that's the type of polygons that we're going to find the area for. Now, these are different because what we're going to do is we're actually going to look for triangles inside of these figures. So as you see in this first example, it has a dotted outline of a triangle, and we have a base of x and a height of h. This is because we're going to try to build a formula based off of this. So how do we find the area of a triangle? Well, area equals 1/2 base times height. So area equals 1/2. Our base in this example is x, and our height is h. All right, so that's how we would find the area if we were just looking for that one triangle inside. But you have to think this is a regular pentagon, penta meaning 5. So if it's a regular pentagon, that means that we have 5 triangles that we can build out of this. And now I'm not doing the best diagram, and I don't necessarily know if this is drawn to scale. But if you were to imagine that we would get 5 of the exact same triangles inside of that, then all we would need to do is multiply whatever we get our answer over here by 5. All right, so the final product would be area equals, I'm just going to put everything on the top. 1/2 xh times, and then it would be the number of sides, so it would be n. So in this case, our n equals 5. But the general formula that we're going to find for this, we'll talk about this a little bit more of what h and x are going to represent. This is how you find the area of regular polygons. And the n is what's going to be changing every time, as well as the side lengths. And we have a special name for the height. So now I'm going to scroll down here. Okay, so this dotted line here on this figure, this is an octagon. This is a regular octagon, we're going to assume. So the distance from the center of a regular polygon to any of its sides perpendicular. This is called the apothem. Kind of a cool little word. Notice the apothem has to be perpendicular from the center. So technically there's 8 different apothems because there's 8 different sides to this regular octagon. So we could have an apothem that goes like this. And then it just has to be right angle. So it's going to actually be perpendicular, and it's going to bisect the side that it touches. So it's going to cut this bottom piece in half into 2 congruent parts. Now the area of a regular polygon. So if we're using the apothem, here's what our formula is going to look like. Area equals 1/2, because remember we were talking about the triangles earlier. A, which stands for the apothem, times the perimeter. Okay, and I'll write this down here. A equals apothem, and P equals perimeter. Or another way we can do this, area equals 1/2 A times N times S. A is still the apothem, N is number of sides and then S equals side length. Okay, now the one on the right is closer to the formula we talked about up above. Okay, so if we want to find the area of this octagon, I'm just going to give it a side length. We're going to say that each side is 8. We'll go 8 centimeters, just so we have a little label. Now thinking about that, we were talking about triangles before. If we were to create a triangle, so I'm just going to do my dotted line here. Okay, so now I have my triangle. If this is 8, which means this side down here is also 8, and the apothem cuts it in half, we get a 4 and a 4 on each side. Now that helps us, but what we need to find in order to get the apothem, because we don't know what that value is, we need to figure out what is this angle right here, or this angle right here. Technically they're going to be congruent. The way we do this is what we learned last week, which is we need to find the interior angle measure. So that formula is n minus 2 times 180 divided by n equals the interior angle measure. So we're just going to call that, I'm just going to call that x for now. So our n in this case, since it's an octagon, we're going to trade those out and we're going to replace this with 8. So it's 8 minus 2 times 180 over 8. If I type this in my calculator, 8 minus 2 is going to give us 6. 6 times 180. This is going to be 1080 over 8. Divide that. We get 135. Okay, so what we found here, this angle right here, technically, because it wouldn't be cut off just yet, is 135. 135 degrees. But if our triangle is created, that's actually going to cut it in half. So we need to take half of that 135. And we get 67.5 is going to be this angle on the inside of the triangle. I know this seems kind of weird. This is not an easy concept, so I apologize. So we got 67.5 and we have 4. How can we use an angle and a side to find another missing side? Well, if you recall, we learned how to do this earlier in the year using trigonometry. So what I'm going to do is I'm going to call this is my A, because that's the apothem. So to use trigonometry to solve for this, I'm going to go with, I need to figure out which sides do I have. Remember SOHCAHTOA. So we have sine, cosine, tangent are the options to use. In this problem, we would want to use the opposite side and the adjacent side, which is 4. Opposite and adjacent is tangent. So the tangent of 67.5 is equal to A over 4. Opposite over adjacent. And if you recall, how we solve for this is you multiply by what's ever on the bottom. So you will need to type in the tangent of 67.5 into your calculator. And it's about 2.414, and then multiply that by 4. So we get A is approximately 9.6, we'll just go 66. Okay, so now that we have our A, we need to figure out the perimeter of this figure, and then we can put everything into our formula. I'm going to erase what I had over here. I apologize. All right, so area equals 1/2. We found the apothem is 9.66. We need to figure out what is the perimeter. So to find the perimeter, it's an 8-sided figure, and if each side is 8, you just take the number of sides times the side length, which would be 8 times 8 equals 64. So P equals 64. All right, now we got everything we need. Let's type this in our calculator. And we get 309.12 if we're doing the rounding. Okay, and then we'll label that as centimeters squared since it's area. All right, that's a lot of work. It's probably a lot to think through. So I'm got some more problems to do here. Hopefully we'll have a little bit more room. All right, next we're on to a different figure here. Our goal is still to find that apothem. So I'm going to call this A. I'm going to draw in my triangle here just to remind you that's what our goal is. We know each side length is 10 centimeters, which means if the apothem cuts it in half, we have 5 here, 5 here. Another thing that we need to do is we need to figure out this angle, and then we want to cut it in half. So I'm going to use that formula for the interior angles again, n minus 2 times 180 divided by n equals that angle. I guess we could call it x or something else. In this case, this is a pentagon, 5 sides, so I'm going to replace n with 5. Okay, so 5 minus 2 is going to give us 3. 3 times 180 is 540 over 5 equals x. So now we want to divide that by 5. X equals 108. So this whole thing here is 108. Or the whole angle that I was talking about over here on the left is 108. We need half of that because our triangle is going to cut it in half. So let's take this and divide it by 2. And that's going to give us 54 degrees. Okay. All right, so now we have the angle. We know that our base of this part here, if we're looking at just the left side of the triangle, that is 5. So again, we need to use trigonometry to solve for the apothem. Since it's the same setup as the last problem, we want to use tangent, and we have to use tangent for this. So tangent of our angle this time is 54 equals opposite over adjacent. So the opposite side is A, the adjacent side is that 5. To solve for A, multiply by what's on the bottom. Make sure your calculator is in degrees, not radians. 5 times the tangent of 54. We get A equals 6.88. All right, there we go. So now we got A. Remember our formula is area equals 1/2 A times P. We figured out A, that's the apothem. Now we need to figure out the perimeter. Perimeter for this one's pretty nice. So each side is 10. It's a regular pentagon, so all sides are 10, and penta means 5, so perimeter equals 10 times 5, which equals 50. Area equals 1/2, and then the apothem we found to be 6.88, and the perimeter we found to be 50. So let's get our final answer here. Again, this is just one of those lessons that the more you practice it, the better you get, just like with everything in math. 172 centimeters squared. That one ended up being pretty nice. Okay. All right, give you a little time to just write that down. This one's a little bit different. This is our last example here. We want to calculate the area of this pentagon, because it's still 5 sides, but this time we are given not the apothem. Don't let this confuse you. The apothem has to connect to the center of one of the sides. So technically, this is the apothem right here. So this is our A. We still need to figure that out in order to calculate the area. This one, what we're missing though, is we don't know what our side lengths are. So we don't know the distance of each side. So I'm going to introduce another variable down here. This is going to be our x. And then the whole thing has got to be 2x because it's got to be double that. Well, the thing is we can still figure out the angle. Remember, we would use our n minus 2 times 180 divided by n, and it would equal our angle and use theta, which is this here. But we just did that in the last problem. We know that it's going to end up being that 54 degrees again since it was a pentagon. So this is 54 degrees still. If it was a different figure, you would just change out n for the different number of sides. But here's 54. So we can solve for both a and for x using trigonometry. But now, which side do we have of this triangle? This is still a right triangle. We need to think about what does a represent, what does x represent, and what does the 20 represent? Well, 20 is actually the hypotenuse. So to solve for a and x, we're going to use two different trig equations. The first one we're going to use is sine. If you remember, sine is opposite over hypotenuse. So opposite of our 54 degrees is a. So a over 20. So to solve for a, we're going to multiply both sides by 20. Sine of 54 times 20 is approximately 16.18. Next thing that we need to do, we're going to do the same setup, but now we're going to use cosine. Cosine of 54 is equal to, now we've got to use x over 20. My pen is going to die. I got to rush this a little bit. Okay, so we would solve, because cosine is adjacent over hypotenuse, we'd still multiply by what's on the bottom. 20 times cosine of 54, and we get x equals 11.75, or 76 if we're rounding, excuse me. And I'm going to be pretty lenient on the rounding, so don't panic too much about that. But we need to figure out what 2x is, because that's going to be the whole side. So let's take this times 2. So this, the whole thing has got to be 23.5, hold on, 52. I did the unrounded version. So that's what this is. So each side length is 23.52. So let's take that times 5 to get the perimeter. So P equals 23.52 times 5. 117.6 centimeters is the perimeter. The area, recall, is 1/2 times A times P. So area equals 1/2. Our apothem we found earlier was 16.18. And then the perimeter we just found to be 117.6. So let's plug this in our calculator. And we get 951.38 centimeters squared. This definitely might be a video that you want to watch a couple times. It's definitely a messy set of work, so you're probably going to want to have some scratch paper. I apologize for the length of this, but hopefully it gets better the more you practice it. Don't feel bad if you need to reach out. Again, I still have office hours from 1 to 3 every day, and if that doesn't work for you, let me know and we can find a different time. But I hope you guys are doing well. I miss you a lot. I'm sure the news that we won't be coming back is pretty sad. Fortunately, everybody in this class, or, well, depending on which geometry class you're in, you'll be able to return at some point. But just keep up the good work. Know that I appreciate it. And if you need help with anything, even besides math, please let me know.